Microsoft introduced a new chip that is Majorana 1, the world's first quantum chip powered by new topological core architecture, and it expects will realize quantum computers capable of solving meaningful industrial scale problems in years, not decades. Before it were took decades to solve some problem that was industrial and complex problems, and it will be solved in some years. It leverages the world's first topological breakthrough, a breakthrough type of material which can observe and control Majorana particles to produce more reliable and scalable qubits, which are the building blocks for quantum computers. In the same way, the invention of semiconductor made today's smartphone, computers and electronics possible. Topo conductors and the new type of chip they enable offer a path to developing quantum systems that can scale to a millions qubits and are capable of tackling the most complex industrial and societal problems.
Now the question arises that what is the Majorana particle that the Microsoft team has used. So Majorana particles are hypothetical particles that are their own antiparticles. They are predicted in 1937 by Italian physicist Ettore Majorana. Properties of the Majorana particles are as follows. They are self-antiparticles, meaning they have the same properties whether they are viewed as a particle or its antiparticle. They are resilient to noise and they get their mass through a unique self-interaction. The Majorana particles equation describes the wave functions of these particles. The creation and inhalation of rates of Majorana families are identical. These are some applications of the potential applications of the Majorana particles. That Majorana particles could be used to build quantum computers and they could be used to create stable quantum bits. In 2018, Leo Bohnon and colleagues claimed to have found Majorana particles in a semiconductor nanowire covered by a superconducting layer. However, retraction of the paper put Majorana research on a new path. The only possible candidate for a fundamental Majorana family in the standard model is neutrino. Now, let me tell you about the qubits. Qubits or quantum bits is a unit of information in quantum computing, and it's a quantum version of a classical binary bit. Qubits are the building blocks of quantum technologies. Qubits are represented by superposition of multiple possible states. Qubits can represent 0, 1 or any proportion of 0 and 1. Like binary digits were only 0 and 1. There were two only options, that is 0 or 1. But in qubit there are some proportions. There may be some proportion of 0 and 1. Means this is not binary. This is the qubit rather than 0 and 1. Qubits are quantum mechanical phenomena like superposition, interference and entanglement. Qubits can be made out of quantum systems like an electron or photon. Some Microsoft teams professionals were saying that this Majorana particle is also other than the electron. This is the fraction of the electron. But qubits are more powerful than classical bits because they can exist in superposition states. Means there is no need of 0 or 1 or only two-way. Qubits can be subjected to incompatible measurements and entangled with other quantum bits. Qubits allow quantum algorithms to process information faster than classical system. Just like a binary bits, qubit is the basic unit of bits is the basic unit of information in classical or traditional computing. A qubit or quantum bit is a basic unit of information in quantum computing. Quantum computing is driving new discoveries in healthcare, energy, environmental systems, smart materials, and beyond. So, a qubit uses the quantum mechanical phenomena of superposition to achieve a linear combination of two stages. A classical binary bit can only represent a single binary value, such as 0 or 1, meaning that it can only be in one of two possible states. A qubit, however, can represent 0, 1 or any proportion of 0 and 1 in superposition of both states. With a certain probability of being 0 and a certain probability of being 1. Superposition allows quantum algorithm to process information in a fraction of time. It could take even the fastest classical systems to solve certain problems. The amount of information a bit system can represent grows exponentially. Information that 500 qubits can easily represent would not be possible with even more than 2 to the power of 500 classical bits. It would take a classical computer millions of years to find the prime factor of 2048 bits number. Qubit could perform a calculation in just minutes. Where classical computers use familiar silicon-based chips, qubits, sometimes called quantum computer bits, qubits can be made from trapped ions, photons, and artificial or real atoms or quasi-particles. Can you focus on the words that I'm using? Qubits can be made from trapped ions, photons, artificial or real atoms, or quasi-particles, depending on the architecture and qubit system. Some implementations need their qubits to be kept at atmosphere close to absolute zero. Superposition enables quantum algorithm to utilize other quantum mechanical phenomena such as interference and entanglement. Together, superposition, interference, and entanglement create computing power that can solve problems exponentially faster than classical computers.